Hello, our dear students. We are going to study lesson 3 in unit 1 in algebra, addition of rational numbers. First, addition operation when adding two rational numbers with the same denominators, okay? If we have a over b as a rational number and c over b also belong to q as a rational number, so when we adding these rational numbers together, the answer will be like that. A over b plus c over b will equal adding the numerators only and put the denominator one time down, okay? So the answer will be a plus c over b. Now, when adding two rational numbers with different denominators, a over b plus c over d. First, we multiply the denominators together to get bd, like that. Then, divide the new denominator by the denominator we have. So bd divide b will equal d. So the new numerator will equal ad plus, by the same way, bd in the denominator, dividing it by d to get, cb. So we have here ad plus cb all over bd. Now let's have some examples. First one, 3 over 8 plus 1 over 4. Now we have 4 and 8 in the denominators, so we studied before to multiply the denominators. So we have 32 in the denominator, divide 8, we will get 4 times 3 plus 32 divided 4 equal 8, times 1 in the numerator, so it will be 12 plus 8 over 32, which is equal 20 over 32. In the simplest form will be 5 over 8. Another example, 2 over 7 plus 5 over 7. We have here the same denominator, not different. So we add the numerator together only and put the denominator one time, like that. 2 plus 5 over 7. It will be 7 over 7, which is equal 1. Another example, negative 4 over 5 plus negative 3 over 2. The LCM of the two denominators we have here, 5 and 2, is 10. So we write the denominators as 5 times 2 for the two terms, like that. Okay. The numerator will be 2 times 4 in the first term, and in the second term 3 times 5, so it will be like that, negative 8 over 10 plus negative 15 over 10, which is equal negative 23 over 10. Another example, 3 and 1 over 4 plus negative 2 and 1 over 3. First, we convert those mixed fraction to the improper form, or the improper fraction, like that. 3 times 4 plus 1, and put the denominator 4. 3 times 4 equal 12 plus 1, it will be 13 over 4. The other term, it will be 3 times 2 plus 1, so it will be 7 over 3, but with the negative sign. Now we have the two different denominators, 4 and 3. The LCM of 4 and 3 will be 12. So it will be 12 in the denominator, and in the numerator 3 times 13 in the first term, plus negative 4 times 7 over 12. In the simplest form, it will be 39 over 12 minus 28 over 12 equals 11 over 12. One and 5 over 8 plus negative 7 and 3 over 4. Those are also mixed fraction. We will convert them to the improper fraction like that. 8 times 1 is 8 plus 5 will be 13 over 8 minus 4 times 7 will be 28 plus 3 to equal 31. Now we have the two different denominators, 8 and 4. The LCM of 8 and 4 will be 8. Yes. So the two new fraction will be 13 times 1 over 8 minus 2 times 31 over 8. It will be 13 minus 62 over 8, which is equal negative 49 over 8 in the simplest form. Now let's have lesson 4, properties of addition operation in the set of rational numbers Q. First property called closure property. Yes. For example, the sum of any two rational numbers is also a rational number. Example number 1. If we have 1 over 2 plus 1 over 3, yes, this is a fraction plus another fraction, so the result will be also a fraction belong to the rational number Q. We have here 1 over 2 is a rational number. Also 1 over 3 is a rational number, so the result will be also a rational number. So the addition operation is closed over, yes, the rational number. The rational number is closed over the addition operation, and this is the closure property. Okay. Second property is commutative property. What is the meaning of commutative? Yes, let's have some examples. For if we have a and b are two rational numbers, so we say that a plus b equals b plus a. So the result will not change if we exchange the places of the two rational numbers together. Let's have an example. 3 over 4 plus 2 over 5 will equal, yes, 15 over 20. By the same way we studied in lesson 3, for the addition operation, we have 4 and 5 in the denominator, having the LCM 20, so it will be 15 over 20 plus 8 over 20, which is equal 21 over 20. Yes. Having the same example by exchanging the places of the fractions. 2 over 5 plus 3 over 5 will equal, yes, 8 over 20 plus 15 over 20, which is equal, yes, 21 over 20. The same answer. So the commutative property is satisfied for addition operation in rational number. So we can say that 3 over 4 plus 2 over 5 equals 2 over 5 plus 3 over 4. We exchange places only, but the result is the same. The third property is the associative property. If we have A and B, A, B, and C are three rational numbers, so we can say that A plus B in two brackets plus C outside the bracket equals A outside the bracket plus B plus C inside the brackets. Let's have an example. 3/7 plus 1/7 plus 2/7. We put the brackets over 1/7 and 2/7. So the answer will be 6/7. Now, if we exchange the places of brackets like that, 3/7 plus 1/7 inside the brackets plus 2/7, it will be also 6/7. And this is the associative property in addition operation in rational numbers. Number 4, the identity element property. What is the meaning of identity element in addition operation? If we have A as a rational number, so if we add A plus 0, what the result will be? Yes, the result will be the same rational number. So adding by 0 give me the same rational number. So 0 here is the identity element in addition operation. A plus 0 equals 0 plus A equal A as a rational number belong to Q. Yes, so 0 is the identity element in addition operation in Number 5, the additive inverse property. What meant by the additive inverse? Yes, if we have a rational number A, so the additive inverse of this number will be the opposite sign of this number. It will be negative A. So A and the negative A are the inverse of each other. If we add the number and its inverse, we will get 0. So A plus negative A will be 0. So the additive inverse of any number is the number with the opposite sign. Okay, 5 is the additive inverse of negative 5. Negative 7 is the additive inverse of 7, and so on, because if we add 7 plus negative 7, we will get 0. Example number 5. Use the addition properties in Q to find the result of the following. 6/35 plus negative 5/11 plus 19/35 plus 5/11. We must first exchange the places to have the same denominators together, the same fraction with the same denominators together, and this will be the commutative property as follows. So we have 6/35 plus 19/35 plus negative 5/11 plus 5/11, commutative property. The second step will be 6/35 plus 19/35 inside two brackets, okay, plus inside two other brackets negative 5/11 plus 5/11, and this is the associative property. Okay, the next step will be to find the result of addition in each brackets we have. So we'll have, yes, 25/35 plus 0. Getting 0 here by having the property which is called the additive inverse, because we have negative 5/11 and 5/11. Okay, now we have 25/35 plus 0. Any number adding by 0 will be the additive inverse property? Yes, it will be, yes, the additive identity property. So we get the same number, 25 over 35, which is equal 5 over 7 in the simplest form, belong to Q, and that is the closure property. Now let's have some exercises in lesson 3 and lesson 4. First, complete the additive identity element in Q is, yes, 0. The additive inverse of the number 3 over 7 will be, yes, negative 3 over 7. The additive inverse of negative 6 over negative 11. Negative over negative will be positive, so the additive inverse of this number will be, yes, 6. Negative 6 over 11, because we have this number will be 6 over 11. So the additive inverse of it will be with the opposite sign, which is equal negative 6 over 11. Okay. The additive inverse of the number 2 over 3 power 0, all to the power 0. Any number to the power 0 will equal 1. So the additive inverse of 1 will be negative 1. Okay. The additive inverse of the number negative 4 over 5, but in the absolute value. The absolute value of any number is the positive sign with this number. So negative 4 over 5 will be 4 over 5. And the additive inverse of 4 over 5 will be negative 4 over 5, like that. Okay. Calculate 1 over 4 plus 25 over 8. We have here the different denominators, but the LCM of 4 and 8 will be 8, like that. Okay. So by the same way we solved it before, it will be 2 times 1 over 8 plus 1 times 25 over 8. It will be 2 plus 25 over 8. In the simplest form, it will be 27 over 8, like that. Number 2, 5 over 9 plus the absolute value of negative 4 over 9. Okay, the absolute value of the number is the positive value of this number. So it will be 5 over 9 plus 4 over 9, which is equal, yes, 9 in the denominator, and 5 plus 4 equal 9. 9 over 9 equals 1. Another example, negative 3 over 9 plus negative 2 over 5. The LCM of 10 and 5 in the two denominators, having the LCM 10. Okay, like that. It will be negative 3 over 10 plus negative 4 over 10, which is equal negative 7 over 10, like that, in the simplest form. Use the property of addition operation in Q to find the result of each of the following. 1 over 4 plus 1 over 2 plus 3 over 4, without using calculator, using only the property of addition operation in Q. So first we use the commutative property as follow, and putting brackets, so it will be associative property, like that. It will be 3 over 4 plus 1 over 4 in two brackets, plus outside the bracket we'll put 1 over 2. 3 over 4 plus 1 over 4 will be 4 over 4. Yes, the result of the fractions added in brackets, plus outside the bracket we have half 1 over 2. 4 over 4 will equal 1 plus 1 over 2. 1 plus 1 over 2 will be 3 over 2, and this belongs to Q, and this is the closure property. So we use commutative property, associative property, and the closure property.